Hi, this is the read aloud for Chapter 3, Lesson 2, Seafloor Spreading. The previous lesson we talked about Pangea, the supercontinent, and continental drift. Today we're going to talk about mid-ocean ridges, so deep inside the ocean. What are mid-ocean ridges? When scientists such as Marie Tharp drew maps showing features of the ocean floor, they made a surprising discovery. In certain places, the floor of the ocean appeared to be stitched together like seams of a baseball. The seams curved along the ocean floors for great distances, as shown in Figure 1. Scientists found that the seams formed mountain ranges that ran along the middle of some ocean floors. Scientists call these mountain ranges mid-ocean ridges. So key fact is mid-ocean ridges form long chains of mountains that rise up from the ocean floor. So mountains under the sea. Evidence from climate. Oh, that's last chapter, sorry, page 99. In the mid-1900s, scientists mapped mid-ocean ridges using sonar. Sonar is a device that uses sound waves to measure the distance to an object. Just like dolphins and bats, sonar is a device that uses sound waves to measure the distance to an object. Scientists found that mid-ocean ridges extend into all of Earth's oceans. Mid-ocean ridges lie under thousands of meters of water. Scientists also discovered that a steep-sided valley splits the tops of some mid-ocean ridges. Such as this. So the mountain comes up, but then there's a ridge right there. The ridges form the longest mountain ranges on Earth. They are longer than the Rockies in North America and longer than the Andes in South America. So we have the East Pacific and the Mid-Atlantic ridges on the side. Mid-ocean ridges are right there. So there's mountain ranges right underneath in the water. Ocean floors. Mid-ocean ridges rise from the seafloor like stitches on the seams of a baseball. So we have these mountains, mid-ocean ridges, and then there's that valley shape that's right in there, and we'll explain that in the next page. Page 100. Seafloor spreading. By 1960s, geologists had learned more about mid-ocean ridges. They found that mid-ocean ridges continually added new material to the ocean floor. They called this process seafloor spreading. Seafloor spreading begins at a mid-ocean ridge, which forms along a crack in the oceanic crust. Along the ridge, new molten material from inside the earth erupts, cools, and hardens to form a solid strip of rock. Seafloor spreading adds more crust to the ocean floor at the same time. Older strips of rock move outward from each side of the ridge. So the magma comes up and it piles up on the side, and then as more magma comes up, it piles up and it keeps moving outward, creating these little ridges. Seafloor spreading adds more crust to the ocean floor. At the same time, older strips of rock move outward from either side of the ridge, shown in Figure 2. Evidence that geologists have found for seafloor spreading. So evidence in the central valley of mid-ocean ridges, scientists have found rocks shaped like pillows. Such rocks formed only when molten material hardens quickly after erupting underwater. So pillow lava, that looks fun. Evidence from magnetic stripes. Rocks on the ocean floor form from molten material. As the material erupts, cools, and hardens, magnetic minerals inside the rock line up in the direction of Earth's magnetic poles, north and south, right? These minerals form unseen magnetic stripes on the ocean floor. But the magnetic poles occasionally reverse themselves, so each stripe defines a period when molten material erupted and hardened while Earth's magnetic poles did not change. Scientists found that the pattern of magnetic stripes on one side of the mid-ocean ridge is usually a mirror image of the pattern on the other side. So if you can see, the red is together, the yellow was together, the green is together, and far out enough is blue. So these were formed at the same time, but they spread out. The matching patterns show that the crust on two sides of the ridge spread the ridge at the same time and at the same rate. We'll watch some videos to explain some of this a little better. Evidence from drilling. So we have ocean floor material, the magnetic stripes, and drilling samples are ways that we can tell seafloor spreading. Scientists drilled into the ocean floor to obtain rock samples. They found that the farther away from the ridge a rock sample was, the older the rock was. We do carbon dating for rocks in that instance. The youngest rocks were always found at the center of the ridge. Recall that at the ridge center, molten material erupts and cools to form new crust. The rock's age showed that seafloor spreading had taken place. Keep in mind the rock cycle that we had just learned about. We had igneous, sedimentary, metamorphic, and then it gets recycled back into igneous, or into the lava and the magma, into igneous rock again. So just keep that in mind, that we continue to recycle and reuse the rocks of Earth. Page 101, here's the molten material, comes up, it cools. And as this cools and gets hardened, the next time some comes up, it keeps pushing these away. These are called mid-ocean ridges, and this is the oceanic crust because it's the crust that's on the ocean. This is the mantle. Some mid-ocean ridges have a valley that runs along their center, so it would be this valley right in here, that crease. Evidence shows that molten material erupts through this valley. The material then hardens to form rock on the ocean floor. You can color it in if you'd like. Remember that these two would be the same, then these two would be the same because they were created together and then they slowly got pushed out. Thanks for following along. There's some more questions and pictures you guys can look through in the text. Enjoy.